Tempe Landy. I'm coming at you from Skidmore's chemistry lab with Professor Roca and Jessica, class of 2020, and they're going to show me a little bit about what collaborative research is like here on campus.
Thank you for asking and welcome to our research laboratory. I'm a teaching professor here at Skidmore, and what I do is I try to find ways to make nanomaterials more stable. You might have heard nanotechnology, and there is a lot of study about it. It refers to the study of materials that are in the nanometers dimension. They haven't made many applications because these materials are quite unstable, and in particular the nanoparticle that we study, they like to aggregate. So the materials that we study, particularly silver, they have different properties what they are in the nanoscale. You might remember silver is silver color for your jewelry, but when silver is in the nanoscale, it might take different colors depending on the shades and the size. So this is a novel property that silver has. So our experimenting here is inspired by all the efforts that museums and colleges are doing to introduce people to nanotechnology. And in the experiment, they make nanoparticles that are colored, and they put them in films and try to emulate colored glass. So that's what we're gonna show you today. A solution of silver ions, which is silver plus, and we're going to reduce them. We're going to change them into silver metal. That's called a reduction reaction. And in order to avoid having a mirror of silver, because we get in the metal, we're going to add some protective molecules that are going to keep them in the shapes of nanoparticles rather than precipitating. They're going to stay in solution. So I'm going to do the ascorbic acid, and Jessica's going to do the sodium borohydride. Okay, so you ready?
Wow.
And this is one of the indigo solution.
Cool.
After we make the solutions, then we put them in a polymer, and then we dry them, and we can get films, and the films have the colors of the solutions. This one is the yellow one, and this one is kind of blue one. Ouch. And the important thing is that they are transparent. I don't know if you want to see. You can see the letters in here. That they are transparent, and that's why we use them for these kind of applications on colored glass. But the color gives us information about what the nanoparticles, the sizes of the nanoparticles. It gives us information about how the nanoparticles are behaving with one another, and that's the information that we want to get from these colors.
Great.
The other instrument that we use to characterize the morphology of nanoparticles is the transmission electron microscope. And what it does, the microscope is going to rain electrons on top of our sample, and the samples are going to absorb the electrons. For instance, silver is a metal, is going to interact with those electrons, and then we're going to see a shadow on the bottom that is going to tell us the shape of the nanoparticles. And this is what we get. This is a transmission electron micrograph, and it's showing us that we have, in this case, particles that are kind of triangular particles or spheres particles, and depending on the shape of the nanoparticles, that's what gives us the color.
Cool. Jessica, you were doing some collaborative research this summer with Professor Roca. Can you tell me a little bit about what you were doing?
Yes, definitely. So we're doing research on nanoparticles and how to have a different, to keep a stable color from the solution side up until it goes to the film side. And what we were focusing on was basically how to get the most intense color throughout the whole application, which is more like a day. So that was pretty much it, and our poster was actually based on the simplex optimization of it, where we used an algorithm, which is more of a mathematic part of the side, and we tried to find the components, which is ascorbic acid and borohydride, and how much of the volume of the ascorbic acid or borohydride is needed to get the solution. So that was
Neat. Cool. So thank you for showing me around the lab today. What kind of difference does it make to work with students during the day and over the summer in collaborative research?
Well, I could do all this research on my own, but I love working with my students because I can see new things through the eyes of my students, and they can only work with us because they had the support of the donors like you. So thank you so much for giving Tuesday.